Okay, Algebra 2 kids, I am gone today, and so we're starting Chapter 2. I'll give you your tests back on Tuesday when we come back to school, and so those will all be checked and ready to go for you. But 2-1 is what we're going to start today for notes. I'm not going to go through these examples at the beginning of the chapter, but they have 2 examples, and they have some quick checks that you can do if you want to. I think they give the answer here as well, somewhere in your book, if you want to check with those. But as a quick review, they have like what we did last chapter with graphing linear functions. So we start with this, and then what we'll do is we'll put it into slope-intercept form, or you can find the x and y intercepts like they did. I think a lot of you guys are used to finding the y-intercept, or excuse me, putting it into slope-intercept form, solving for y, and then graphing him from there. So this is what the linear function looks like. Same thing if we have an inequality, which is like this symbol greater than or equal to, we're just going to graph that function starting at -2, so here, and then going up 3 and over 1, and he is going to be a solid line because of this equal to symbol, and greater than shaded above. So that's something that we did last chapter a little bit of, and now we're going to be doing some linear, let's see, maybe go down, solving some linear equations and inequalities, so kind of along those same lines, just dealing with linear functions. A couple story problems in here, trying to get those figured out. So that's just kind of a preview of what we're doing, okay? Things that we are allowed to do when solving, so just to show you what some of these problems look like. So we'll have this here, which kind of looks like an icky thing, but we'll figure them out here in a minute. We have an equal sign, and we're trying to figure out what x equals, okay? So things that we're allowed to do, we're allowed to do the addition property. So this would be an example if you have like x minus 3 equals 2. We are allowed to add 3 to both sides and get x equals 5. Because we do add the 3 to both sides, that's the addition property of equality. We're allowed to do that, okay? The subtraction property would be like, let's say we have x plus 3 equals 2, and we can subtract 3 from both sides and get x equals -1. And because we subtracted 3 from both sides, it is legal, okay? The multiplication property says that, like, let's say we have x over 4 equals 2. Okay, that's like x divided by 4. So what we can do is we can multiply by 4 on both sides to get our answer, to get the x by itself, and we get 8. So we multiplied 4 to both sides, and that's the multiplication property of equality. And then we have the division property would be like, let's say I have 2x equals 4, and I am allowed to divide both sides by 2 in order to get x equals 2, okay? As long as I'm doing it to both sides, I can add, subtract, multiply, divide. As long as I'm doing it to both sides, it stays legal, I guess. If I went through that too fast and you want to pause to write anything down at any point in time, you can pause. So feel free to do that. Example 1. They start us off with some icky fractions, okay? So I am actually going to follow along this list here, and we're going to go through those steps, the same steps that they have, okay? The first thing that they do, let's see, they just rewrote the original equation, okay? So they didn't do anything from that step. They just rewrote the original equation. The second thing that they're going to do is, or I guess first step that they're going to do is they're going to start to distribute that through. So if you take 1/3 times 2, this is like 1/3 times 2 over 1. So 1 times 2 and 3 times 1 would be 2/3, okay? Some of you guys know that. Some of you might be a little bit harder for you to figure out, but you're just taking and multiplying the tops and the bottoms together. So 1/3 times 2 is 2/3, okay? Then if we take 1/3 times 57, okay, I think that comes out to be a whole number. 19 maybe, let me check. Okay, if you are taking it times 1/3, another thing that you can do is 57 divided by 3, right? 1/3 is the same thing as dividing by 3. 57 divided by 3 is 19. Yep, you betcha. Okay, then we're going to do the same thing, 1/3 times 6. This is 6 over 1. So 6 times 1 is 6, 3 times 1 is 3, 6 divided by 3 is 2 if we reduce. Okay, so 1/3 of 6 is 2. Okay, then we do the same thing, 1/3 times x, which is minus 1/3 x, and then that's equal to -4. Okay, so now we've distributed that fraction through, and now we're going to simplify some more, okay? So 2/3 x and -1/3 x, we can put those two together. So 2/3 minus 1/3 is just 1/3 x, okay? And then we've got negative 19 and positive 2, which is going to be negative 17. And then the negative 4 is just hanging on over there, okay? Next, we're going to add the 17 over, plus 17 plus 17, okay? And so I have 1/3 x just by himself, and negative 4 plus 17 is going to be 13, okay? At this point, I'm trying to get rid of the 1/3, and to get rid of 1/3, you can divide by 1/3, or you can multiply by 3, right? Times 3 times 3, and that will get rid of my 1/3, so I'll just have x on that left side, and 13 times 3 is 39, and that's my final answer. Okay, so there was some really ugly stuff in there, some really ugly fractions, but just go through, make sure you use nice handwriting to do that, and go through and just do the fractions like you would normally a whole number. Thank you. All right, let's go through and let's do the second example. Write and solve an equation. So they're going to give us a story problem, and we're going to try to sort it out from here. It says the diameter of Earth is 824 kilometers less than twice the diameter of Mars. That was a lot, okay? So starting here, 828 kilometers less than the diameter of Mars. Oh, less than twice the diameter of Mars. So 824 less than means I'm subtracting 824. That's 824 less than. Whatever I have originally, 824 smaller than that. And then twice the diameter of Mars is going to be 2, let's call it 2m, twice the diameter of Mars. So I have 2m and then 824 less than that. That's what our story problem is sorted out to be, okay? All right, so they have in part A here, they have it like chunked out for us a little bit. They say the diameter of Earth is 824 less than Mars. So they said, let's just assign our variable m to be the diameter of Mars. Diameter of Mars. Okay, and we've kind of used m up here when we did our 2m minus 824, and so that's what we're going to write down below here. Our equation, 2m minus 824, and now we're going to incorporate this 12,756. If Earth has a diameter of 12,756 kilometers, what is the diameter of Mars? So, oh, wait a second, I put that in the wrong spot. Erase, sorry. 12,756 is equal to, that's the is part, and then 2m minus 828. Okay, that's the 828 less than twice the diameter of Mars. Okay, so now all we're doing is we're solving this thing right here, and that's not as bad. In fact, that's a lot easier to solve than what the fractioning thing was up above that we just did, okay? So I'm going to go on to the next page. They have a little bit more room to write, okay? So 12,756 equals 2m minus 828, okay? They write it like side by side, and I don't like this step, the way they've written it. I write it underneath. So we're going to add the 828 over to the other side, and that gets rid of him here. So now 2m is all that's left, and then 12,756 plus 828 is 13,584. You can add that with a calculator if you want. So now if we're at this step, all we have to do is divide by 2. And if we divide by 2, now I have to use a calculator. Let's see. 13,584 divided by 2. And that is 6,792. So that is the diameter of Mars. The diameter of Mars, because that's what we said m was. M was 6,792. Okay, now, they say this is a reasonable solution because 12,756 is a little less than twice what Mars was, right? We said that he was 828 less than twice what Mars was. Okay, so if I double Mars, I get this number, and the 12,756 is a little bit less than that, okay? So that takes into consideration our 2m minus 828, okay? All right, so the actual math of that was not that bad, but getting to the point where we have an equation, that was probably the hard part, okay? All right, so just sort those words out, underline things, just chunk out the paragraph so that you can come up with the 2m minus 824, okay? All right, let's go to the next example, this one right here, example 3, okay? I think I'm gonna do my work over here off to this side, okay? So it says the formula for perimeter of a parallelogram is The perimeter is 2A plus 2B. So like a parallelogram would be like a rectangle. And if A is this side and B is this side, if we're trying to find perimeter, we're adding all of them together, or 2A's plus 2B's. That's where they get this formula from, okay? A and B represent the measure of the bases, so the sides, okay? They want us to solve the equation for B. So we're not plugging anything in, we're not doing anything. They kind of want us to do what's similar to like when we solve for y and put it into mx plus b. They want us to solve for b here and get b by itself, okay? So I'm going to write over here the original equation, 2a plus 2b, and we're just trying to get b by itself. So like we just need to move everything else, okay? So what we'll start by doing is we will move the 2a. Okay, can you subtract 2a from p? No, you can't, because they are separate variables. So I would just do p minus 2a, okay, equals 2b, okay? And then the last thing that I would do is divide by 2, okay? But I have to divide all of the pieces by 2, okay? So over here, b is just going to be by itself, which is what I want to have happen. I would just want b by itself. But then p over 2, I'm just going to leave that as p over 2. That's the same thing as like 1/2 p if you want to. I'm just going to leave them as p over 2. But then these 2's right here can cancel. So I just have minus a. So b is equal to that stuff. Okay, p, the perimeter divided by 2, and then subtract a. That's what he will look like, okay? All right, so that was, yep, they wrote it right here. P over 2 minus a equals b, okay? There is that problem. All right, if we go to the next one, I don't know. I'm not gonna teach you to solve linear equations by graphing, so you can, I guess don't cross it off. Don't cross it off. Don't cross it off. One thing that I will from here is talk about a root and a 0, okay? So when we're looking at a graph, when we're trying to find a solution, another name for a solution is a root or a 0. Those all have the same name. Solution, root, 0. I'm trying to think what else. Yeah, those are the main ones that you'll hear. But what they're asking for is they're just asking for this point right here. So like what x equals? X equals whatever. And in this case, x is -2. That is the solution. Oh, another name for them is the x-intercept. Okay, so a solution or a root or a 0 or an x-intercept, they all mean the same thing, and it's when you're solving for x, okay? So if you ever see those, that's what they're asking for. 0, root, x-intercept, solution, any of those, it's just asking for what the x is, okay? So they want us to do this by graphing. I'm just gonna practice doing this one without graphing, so let's just solve him like we would normally, but remember that this is what a root or an x-intercept would be. So I have my x here, I've got my 11 here, and I've got my -8 here. So what I would do is, I'm not gonna follow their work down here, I'm gonna work off to this side over here. The first thing that we would do is try to get x by itself is to add the 11 over, okay? So 1/2 x, he's gonna stay himself, and if I add the 11 over, -8 plus 11 is gonna be 3, okay? If I try to divide by 1/2 to get him to the other side, instead of dividing by 1/2, again, I'm gonna multiply by 2. Okay, and that's going to cancel the 1/2, so I just have x equals, and that answer is 6. Okay, so that is my solution. Okay, if we were to graph this, they get him down to the point where they have y equals 1/2 x minus 3, so they like set him equal to y once they get everything on one side, and they go ahead and graph the -3 and then up 1 over 2 and up 1 over 2, and they do that, and when they graph him, they find that the root or the solution or the x-intercept or the 0 is x equals 6. That's where he's going to cross, okay? So they just do it a weird way. I don't usually teach the graphing method, but that's what you're trying to find. When they give you this, keep in mind that when we get x equals 6 as an answer, that's what it means, is that it's where it crosses on the x-axis, okay? So that's how that works, okay? Let's go to this one right here. The Empire State Building run is a race in which athletes run up the building's 1,500 stairs, 1,500 plus stairs, and it says that this guy, Paul Craik, he has the fastest running time to go up these stairs, and he can do 165 stairs per minute. That is like 2.5 stairs a second. That's a lot of stairs. He probably, I don't know, goes up like 2 at a time, you know, like skip steps. I don't know. So when they're looking at this, it's saying, let's see. Yeah. This is the equation for him running up the stairs. So this is the initial, and then every minute he can go 16 or 165 stairs. So you're subtracting that as you go down. So if we look at that as a graph, they're just wanting us to interpret this, okay? So he's starting with this many stairs, like just a little less than 1,600. And as time goes this direction, as we increase in time, the number of stairs that he has left is going down, okay? They're saying find the 0 and interpret the meaning, okay? The 0 is going to be over here. So it's like maybe like 9.5, right? Is what X will be. X was 9.5. And then what does that mean? What does 9.5 mean? That means that it takes him, not the average person. It would take me longer than 9.5, maybe 9.5 hours to do that. It takes him 9.5 minutes to complete the stair challenge. Okay, so that's the interpretation of that. We've kind of done a little bit of that. I think you had a test question that was kind of like that. Interpret the x-intercept or interpret the y-intercept. Okay, so it takes 9.5 minutes to complete his stair challenge. All right, a couple left. Let's go to inequalities now. Okay, so we've talked about inequalities before already when we were graphing them. So that involves like some shading and stuff. So they have like symbols, greater than, less than, greater than or equal to, less than or equal to, that type of thing. You are still allowed to add and subtract. So even though I have like x plus 3 is greater than 2, I still am allowed to subtract from both sides, and it would be x is greater than -1. I still have that. The only difference is when you multiply, divide, maybe put a little star here, okay? Let's say I have -2x is less than 1, right? So what I would do to divide that, if I'm dividing by negative or multiplying by a negative, I would divide both sides by -2. X would have to be, I would have to flip this sign. If you multiply or divide by a negative, you have to flip the symbol, and you guys know that already, I hope. So that would just be -1/2. Now notice that like some of you guys get tricked on this. This negative can come out here to the side, right? 1 divided by -2 is the same thing as -1/2. I just moved the negative out to the front, okay? So remember that you have to flip the sign when you multiply or divide by a negative. So flip sign when times or divide by a negative. That's what we need to make sure to do, okay? So that's why this box is so big. They're just saying, make sure you flip the sign. All right, let's go down and let's do an example. Again, pause if you need to pause, okay? Solve a linear inequality. So this one, we have 3 pieces here. 1, 2, 3. Here's my symbol, okay? And what we're doing is we're solving for n, okay? So he's the only variable. So the first thing, I'm going to go over here. I don't like when they write it side by side. Like, I don't like when they're wanting you to say -12.9. I don't like it when they write it sideways. I like to write it up and down. So let me find some room. We'll just go here. -5.6n plus 12.9 greater than or equal to -71.1. Okay, so the first thing I'm going to do is subtract the 12.9. Okay, and -5.6n is going to be greater than or equal to, this is going to be, try to do it in your head if you can. Since those are both negative, we're just going to add them together. So like 0.1 and 0.9 would be 0.0. I'm going to carry the 1. That would be 4 and what, 8? 84.0, -84.0. So if they have the same sign, you're just going to add them together, right? And that's what he would look like. Okay, last thing, I'm going to divide by -5.6. Okay, so n is going to be, and here's the thing, we have to flip the sign, less than or equal to. If it has an equal to symbol, you keep it there. It doesn't change, right? But he's going to flip the arrow of the sign, okay? Now a negative divided by a negative is going to turn to a positive, and we've got 84, I'm going to do this on a calculator, 84 divided by 5.6, and that is 15. So n is less than 15, okay? If we then go to graph that on a number line, okay, they went ahead and gave us a number line. 15 is right here. This is my 15 mark, okay? So if I graph this on a number line, n is less than or equal to, okay? That's going to be a solid dot, and less than or equal to means he's going this direction, okay? If it was greater than, so less than or equal to, greater than or equal to, those are going to be solid dots. Let me write your little key code here. Less than or equal to is a solid dot going that way. That looks solid. Greater than or equal to a solid dot going this way. Less than, just in general, is going to be an open dot going this way. Greater than is going to be an open dot going this way. Okay, so that's what those symbols look like. Okay, just less than or greater than, those two symbols are meaning up to that number, but not actually including that number. Equal to means I'm physically touching that spot, so it's a closed dot. Okay, so that's how you would graph those, because I think a couple on your homework assignment wants you to graph that. Graph them that way, okay? Let's go ahead and let's skip example 7. That's a story problem, okay? I just don't want this video to be too long. You can try it if you want to. You can go through and look at how they have done that if you want some practice. But we'll go ahead and skip that guy. So that is all I have for you for notes. And the homework is this set. So 2 through 16, the evens, and 26 through 32, the evens, okay? I think the only ones that you have to graph are like maybe 26 and 28 or something like that. I don't remember, but anyway, so there's those, okay? So start working on those. Use the rest of the period to do that, and you're good to go, okay?